Okay, so now we're going to do our in-class exercise. Make sure that you print out the spreadsheet with the questions before you go through this video. It will definitely make it easier. So we're going to start out with our cohort study where we're following 100 participants exposed to their place of work to volatile compound Y for development of cancer of the liver. We start on January 1st, 2010 and follow them for 1 year. So the first thing we have is 2 participants are determined to already have liver cancer. So here you can see I've got 2 participants with liver cancer throughout the duration of the study, and each of them contribute 0 person months. Next, we've got 2 people develop liver cancer on February 1st, and one of them dies on July 10th. So we've got our 2 people who develop on July 1st. Here we've got our one who dies on July 10th, and the other one is there for the entire study. They each contribute 1 person month. Then we have 3 people who develop liver cancer on March 1st. So here we've got our 3 on March 1st. They each develop cancer on March 1st, so they each contribute 2 person months follow-up. Then we have 2 who are lost to follow-up on July 10th. So here we've got our 2 who are lost to follow-up. They each contributed 6 person months of follow-up. And finally, we have 1 who develops liver cancer on September 10th and dies December 1st. So here we've got that person, and they die on December 1st, and that person contributed 8 persons months of follow-up. Then we have persons number 11 through 100. So that's our 90 individuals who each contributed 12 person months of follow-up each. That gives us 1,080 person months. When I sum all of these numbers up, I get a total in the exposed group of 1,108 person months of follow-up. Now let's look at our unexposed group. We have 1 who develops cancer on August 1st. So here's our individual who developed cancer on August 1st. They contributed 7 person months of follow-up. Then we have 2 more who developed cancer on September 1st, and one of them dies on December 1st. So here we have that individual who contributed 8 person months of follow-up. And finally, I think that's it. Yep, that is it. And then we've got persons number 4 through 100 are 97 individuals who each contributed 12 months of follow-up for a total of 1164 person months of follow-up. When we add that 1164 up with our other people, we get a total of 1,187 person months of follow-up in our unexposed group. So now we've got all the information that we need. The first thing we're going to do is calculate the relative risk of developing liver cancer when exposed to volatile compound Y using incidence density. So the first thing that we want to do is set up the appropriate 2x2 table. So here you see we've got that right here. So in our exposed group, we want to figure out how many new cases of cancer there were. So we got 1, 2, 3, 4, 5, 6 new cases. Remember, these 2 individuals who came into the study with disease did not count. And then in our unexposed group, we've got 3 new cases. So we put a 6 for our new cases in exposed and 3 in our new cases for unexposed. And then we need the total number of person months for both our exposed and our unexposed. To come back to our chart, we've got 1108 months for our person months for our exposed and 1187 for our unexposed. So we just put those numbers in. 1108 for the exposed, 1187 for the unexposed. Now we've got relative risk is equal to the incidence density of the exposed divided by the incidence density of the unexposed, which is just 6 over 1108, all divided by 3 over 1187, which gives us 2.14. Remember, we have to put it into a sentence. So those exposed to volatile compound Y are 2.14 times as likely to develop liver cancer as those not exposed to volatile compound Y. The next problem is using cumulative incidence to calculate our risk difference. So we need to do our risk difference 2x2 table using cumulative incidence. So for a cumulative incidence 2x2 table, again, we've got the number of new cases in the exposed and the unexposed, which is again just 6 and 3. Then we need the number of individuals at risk who did not develop disease. So let's go back to our 2x2 to our chart. So there are 2 people that we need to knock out because they were not at risk at the beginning of the study. So that leaves 92 people who were at risk of developing disease but did not. 6 at risk at the beginning who did develop disease, for a total of 98. So remember, those 2 individuals who came into the study with disease do not count in our total population. Now we need to go back and look at our unexposed. Again, we know we've got 3 people who developed disease during the study, and it looks like our entire population was at risk at the beginning of the study. Nobody came in with disease or for some other reason not at risk of developing the cancer. So we've got 3 people who developed disease, 97 individuals who did not, for a total of 100. Then we just come down to our calculation for risk difference, which is risk difference equals the cumulative incidence of the exposed minus the cumulative incidence of the unexposed. So risk difference equals 6 divided by 98 minus 3 divided by 100, which gives us an answer of, when we let Excel do that for us, gives us an answer of 0.03122. Multiplying that out by 100,000, we get 3122. So now we can say the excess occurrence of liver cancer among those exposed to volatile compound Y is 3122 per 100,000, or if exposure to volatile compound Y causes liver cancer, then 3122 per 100,000 could be eliminated by eliminating exposure to volatile compound Y.